Hi guys, greetings of the day. I Vijay Tavardhan, welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester as well as Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 30, which is based on a dwell position of a cylinder. What is called as dwell position of a cylinder? In case of a double acting cylinder, use of 4 by 2 DC valve and a change of position from normal to actuated and actuated to normal position, extensions and retraction of the cylinder respectively. Retention or holding of the cylinder either in extended or retracted position during for a particular duration of time during a continuous operation of the cylinder is called dwell position of the cylinder. Now let us understand with an example. Example of a necessity of a dwell position. During a drilling operation of a number of components, the components are held in jaw, holding fixture and taken out of the fixture after the operation and another job is loaded onto the fixture. Now the figure shows the block diagram of drilling operation, corresponding fixture and extension and retraction of the cylinder. The job is secured in the fixture by extension of the cylinder during the drilling operation and the cylinder is said to be in dwell position. Dwell position of the cylinders can be achieved using 4 by 3 center position DC valve. Now let us understand it more clearly with an image here. Now a circuit diagram as well as working for a dwell position of a cylinder for 4 by 3 DC valve is as follows. Now the port A and port B of the 4 by 3 DC valve is connected to the head end and rod end respectively of the double acting cylinder which you can see in the figure on the right hand side. All other connection, that is, the connection of the pump to port P along with the pressure relief valve and the port T of the valve to the tank. These connections are standard in most of the hydraulic circuit. And upon working, the 4 by 3 DC valve in position 1 in normal position, that is, the port P is connected to T and A and B are closed, which you can observe in the figure very clearly. In this position, the cylinder will be in retracted position. When the valve is brought to position P2, the port P is connected to A and port B is connected to port T. In this position, high pressure enters the head end of the cylinder and extends the cylinder. At the end of extension, the valve is brought to normal position, resulting in port P connected to T and ports A and B are closed and the cylinder will be in extended position, which is called as a dwell position. After completion of the job during the extended position, the valve position is shifted to P3 wherein P is connected to B and A is connected to T, resulting in retraction of the cylinder, during which job is removed from fixture and another job is loaded. After the loading of the job, the valve position is shifted from P3 to P2 at the end of the extension to P1 and this continues. In all the above positions of the valve, with the pump will be on. Shifting the valves from position P2 to P3 or P3 to P2 is by lever and should be held in that position. Once the lever is released, the spring will bring back the valve to the center of normal position. Then coming to a regenerative circuit. In case of a double acting differential cylinder, the speed of retraction will be greater than the speed of extension for a given output of discharge of the pump. This is because the effective area of piston surface is smaller on the rod end side on the cap end or head end side. This is because the effective area of resistance to flow is smaller on the rod end side than that of the head end, which you can observe on the figure on the right hand side. Now we have Q is equal to A into V, where Q is the flow rate, A is the area of the cross section of the flow, and V is the velocity of the bore of flow of fluid and in turn position. Now, by the equation Q is equal to A into V, we can write it as V is also equal to Q by A. For Q is equal to QP, that is nothing but the discharge of the pump. V will be taken as VE for velocity of extension. In the same fashion, V will be taken as VR for velocity for retraction. Then velocity for extension will be given by the formula Q is equal to V is equal to Q by A. In the same fashion, VR is equal to Q by A, since the area on the cap end is greater than the area of the small end. Henceforth, velocity in retraction is greater than velocity in extension, which you can see by the figure. Now, a regenerative circuits are used to increase the speed of the extension of the cylinder than the speed of the retraction, or at least to make the speed of extension equal to the speed of a retraction. To achieve this, the discharge into the cylinder on the head end should be increased. But this is not possible for a given pump, that is, more discharge during the extension and less discharge during the retraction. The principle of regenerative circuit is to increase the discharge into the head end or the cap end side of the cylinder using the oil of the rod end side during extension. Now, figure shows the regenerative circuit of a double acting cylinder differential type using a 3 by 2 DC valve. In this case, the written oil QR on the rod end cylinder is added to the output of the discharge of the QP of the pump, which you can see in the figure very clearly. Now, making the total input of the head end or the cap end side of the cylinder will be designated by QT, where QT is nothing but QP plus QR together is reaching to the cylinder extension side. This results in increase in the speed of the extending strokes of the cylinder. Then, how do we calculate the speed of the cylinder? Now, the regenerative speed will be calculated as follows. Let QP and QR be the discharges of the pump and the return oil on the rod end side as well, head end and rod end side respectively. Let QT will be equal to QP plus QR and the total discharge input to the head end or the cap end side of the cylinder. Let capital A be the capital A and small a be the areas of the piston surface on the cap end and rod end of the cylinder respectively. Now we have a formula, that is Q is equal to A into V, or V is equal to Q by A. That is, the speed of the piston is proportional to the input discharge Q and effective area of the piston surface, which we have discussed in the previous slide. Now, the speed of the piston during the extension will be always proportional to QT by A. Now, but the speed of the oil entering the head end of the piston must be equal to the speed of the oil leaving the rod end. That is, Qt by capital A is equal to Qr by small a, upon which, on further simplification, we can write it Qr is equal to Qt into small a by capital A. And upon which, we also know that the total discharge of the pump to the extension end will be pump plus retraction, which you can see that is what taken here. So upon substitution of these values in this equation, it can be written as QP plus QT into A by A. Upon further simplification, we can write it as QP is taking on the left hand side and QT should be on the right hand side. It could be written in this expression. And then taking QT as a common factor in this expression, as well as taking an LCM, QP will be equal to QT into capital A minus small a by capital A. Now, Qt will be equal to Qp into capital A by capital A minus small a, or it could be written as Qt by A is equal to Qp by capital A minus A, which is nothing but a pump discharge to the area of the piston rod. This is what the speed. That is, the speed will be Qt by A, or it will be Qp by A minus A, which is called as the regenerative speed. By this, whatever the time allotted for this session has came to an end, and thanks for your patience listening for this session number 30. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tamanna.